welcome to my channel Pure Biology, and I'm Tapashi. And today's topic is biotic potential, and that is a topic related to the population ecology. And before going to this topic, I want to say something that I have explained different topics that is related to the population ecology in my previous videos. You just check out that videos, and if you liked that videos, please subscribe my channel because actually I opened this channel for the students, and it will be very helpful. I think it will be very helpful to you that who have taken the different subjects that is related to the biological science, and I will try to give the information about different topics that is very I think informative, and if you will be helpful. Obviously, you will be helpful for following this channel. Okay, so please you share this channel with your friends, and if you like my videos, give one like for each video, and obviously subscribe my channel for the growth of this channel, because it is very new channel, and I had opened it 2021 December. Okay, and also I very thankful to all of you who have already subscribed my channel. Okay, so let's start today's topic, that is the biotic potential. Okay, biotic potential, it is the topic related to the population ecology, and population ecology, you all know what is population ecology, because actually in the environment, if we cannot understand about the populations, so we cannot calculate the number of species that present within the individuals, and obviously different topics that are related to the biological science. Without understanding that topic, I think this within the ecology, the population ecology is very typical chapter, and there are many topics that are very important for this chapter, and it is also hard, okay, to understand. So you just carefully learn this chapter, obviously, and with the help of these videos. Clear? So today's topic is the biotic potential. And what is the biotic potential? Biotic potential actually is the inherent property of an organism to reproduce, to survive. Okay, the inherent, some properties obviously present within the individuals by which they can survive. Okay, they can survive in the changing environment, obviously, and reproduce to give birth the young ones. Okay, so this is the biotic potential. Biotic potential, what is this? Again I repeat that it is the inherent property of the organism to reproduce, to survive. Okay, so all the individuals that remain in our environment, they have the capacity to grow their individuality or to grow their species density. Clear? So that's why they try to reproduce, to produce the more young ones. Okay, and it continuous in every year. Okay, that means the species, the female species or female individual of a species, they have a tendency to grow the individuals that present within the particular species. Okay, so what is this? Actually it is if we just consider according to the algebraic expression, then we can say the number of young, sum of the number of young produced at each reproduction and number of reproduction in a given period of time. Okay, this is the sum. Okay, the sum of the young reproduced at each reproduction and number of reproduction in a given period of time, and also it depends on the sex ratio and the general ability to survive. So biotic potential actually dependent or related to these. Okay, related to these. First one, the sum of the number of youngs produced at each reproduction and the number of reproduction in a given period of time. Given period of time. Second one, the sex ratio. Sex ratio means the male-female ratio. Okay. Third one is the general ability to survive. These are very important, or these are related directly with the biotic potential. Clear? And R equals to, it is denoted by R, and R equals to capital R0 plus S. Capital R0 plus S. And what is R0? R0 means the reproduction rate, and S means the survival or the survival capacity, okay, of the individual. So what we learned here, that is the biotic potential actually the some inherent property that remain within the individual of the species by which they can survive and also reproduce to increase their actual species density. Clear? This is the biotic potential, and it is related to some number of young ones, how much young ones that is produced in at each reproduction, plus the number of reproduction, how much or number of reproduction will occur in a period of time. These are two important factors. Another is the sex ratio, that means the male-female ratio, and the third one is the general ability to survive, that means their capability to survive with the changing environment. These are very important factors that related to the biotic potential. Next we discuss about that when the biotic potential is high or low, what effect of this if the biotic potential become high or low, what effect we can see, okay, or we will see. Number of offspring or the breeding season, the biotic potential, high or low biotic potential, that effect on the number of offsprings per breeding season. Second one, survival up to and through reproductive age. Number 3, age at which the reproduction begin. And number 4, the length of the reproductive age. Okay, so these are the main actual not factor. These are related to the biotic potential. That means if biotic potential is high or low, it affect on this factor or this activity. Okay, if this is BP is high or biotic potential is low, then it create an effective role in that situations or that parts. One is the number of offsprings, second one is the survival capacity, third one is the age, and fourth one is the length of the reproductive age. Clear? So if R is higher, what happens? The high survival rate. Obviously, R is higher, that means the individuals of a particular species, they have the capability to reproduce the much number of individuals and also survive, and that means the survival capacity is high. Second one, when the R is lower, then the survival capacity is low. Okay, so here we also have to learn that when R is higher, when the breeding situation that occurring at the early age, or it's starting from the early age, okay, it is starting from the early age. Second one, the reproduce repeatedly. So it's very simple that if the breeding season starts at early age, so up to if you consider the lifespan of that individuals, in that situation they reproduce repeatedly, okay. But when the R become lower when the breeds only once. If the individual of a particular species, they can breed only once, or after getting the maturity they can breed, in that situation obviously the R become lower. And as the R lower, that means the survival capacity also lower. Why the survival capacity of lower? Because the individuals that produce very little number of young ones, and as usual, all the young ones, when they become mature, they get the capacity of the reproduction, okay, or they at that time they reproduce to produce the young ones. So in that situation, the survival capacity there obviously effective, or it is affected with the environment. Okay, so because here the span or the reproduction capacity is not repeated. Okay, reproduction capacity is not repeated. Why? Because after getting maturity, they only reproduce, or their reproduction age starts at particular time. Okay, so in that situation, R is lower. Okay. And what happens when the greater R, that is higher R, we know that the survival capacity is high. Okay, so greater R, that means the lesser time required to grow. Okay, it's very simple. If you consider one species and their individuals have the capacity to reproduce at early stage of their life cycle. Okay, so what happens? The number of individuals increase within very less amount of time or less time. So in that situation, the number of individuals that rises and the species density that grow, the species density grow with less time. Okay, species density grow less time. So as usually, if the environment changing, you just consider the environment changing. So what happened? Some individuals, they may be died. Suppose they may be died, but some of them, they can survive because the number of individuals is high here. So tendency of the survival capacity also high in that individuals of the species. Okay, but in case of when the R is lower, that means they breeds only once after getting their maturity. In that situation, the number of individuals is low. So with the changing environment, suppose you consider that number of individuals, they may be died. Okay, they may be died with the environment, they cannot survive with the environment. So what happened? The young ones, not young ones, the individuals that remain or they survive with the particular changing environment, their number is less. Okay, so the actual density of the species can grow with much time. Clear? With much time. This is the actual relation. Okay, and here one thing we have to learn, that is the net reproductive rate. What is the net reproductive rate? That is, we consider R0, and R0 equals to NT by N0. Okay, NT means number of organism and N0 means number of organism at zero level. Okay, this is the net reproductive rate. So before discovering or before discussing about the biotic potential, we just can identify or can analyze this net reproductive rate, but it is not sufficient to identify or to calculate the species density of the environment. But after discovering this biotic potential, it is very easier way to calculate the species density or different species density in the environment. Okay, it is continuous, so I just rub it, and after that I give you some information about the biotic potential. Okay, now we learn that how the R is affected. So some environmental resistance may have effects. Some environmental resistance may have effects on the R value in many ways. Suppose there is an example, you can consider it. Suboptimal environment, even the species with life history traits favoring the rapid profile reproduction will have a lower R value. Okay, because of abiotic factors that lowers the birth rate or slower development. Okay, so what is saying here? That sometimes resistance or some climatic features, you can say, that have that create effects on the R values. Suppose we have taken one example, that suboptimal environment, it is very favorable environment, even species with an environment is favorable for the particular species, and the species with life history traits favoring the rapid profile reproduction occurring in the rapid profile way, okay, but the biotic potential or R value is low. What is saying here? That reproduction rate is repeated. That means the young ones must be produced many number, okay, but R is low here. Why the R is low here? Because of some abiotic factors that lowers the birth rate or slower the development. So some factors are there that actual birth rate, that lowers the birth rate. Birth rate is very low due to presence of such factors, and or sometimes the slower the development is not possible sometimes. So this is actual the biotic potential, that it has many. In one way, the biotic potential create effects on different matter. Sometimes different resistance are there in the environment that also affect on the biotic potential. You can understand? Okay, this is the calculation of R value. How we calculate the R value? This is the actual equation. Not reaction, sorry. This is equation. The NT equals to the N0 e to the power R into T. Okay, this is the equation. The NT equals to N0 e to the power RT. Okay, so we have taken ln in both sides. So what happened? That ln NT equals to ln N0 plus RT. Okay, and just we replace their places. Ln NT minus ln N0 equals to RT. Suppose this is RT. Okay, this is RT. Okay, this is RT. Clear? And after that you can see that R equals to ln is common here. Ln bracket NT by N0 by small t. Okay, this is the actual equation by we can calculate the R value, and we know NT by N0, that is the R0. Okay, NT by N0, that is R0. So how we calculate? R equals to, we can write ln R0 by T. Okay, this is the equation, ln R0 by T. And I explained you what is the R0, what is NT, N0. I already explained. You see just before explaining this part. Okay, so here one thing is very important, that when we calculate the R value, then we must be taken this capital T by replacing the small t. Okay, we can take capital T by replacing the small t. This is capital T. So R value equals to ln R0, capital R0 divided by T. And here T is the actual time period of what? Between the birth of mother and daughter's birth. Okay, this is the time period between the mother's birth or the birth of mother and the daughter's birth. Clear? So there is a sum. You can see this is an sum where we already know. Oh, sorry, no, this is not sum. This is another equation. This is sum. Okay. So here, how we calculate the capital T? Capital T equals to summation of Lx. This is Lx, and Lx mx. Already I discussed in my previous video. You just check out what is Lx and what is mx in the life table, obviously. Lx mx into x by summation of Lx mx. Here, Lx mx into x by summation of Lx mx. Okay, here the value actually you have got the value Lx mx x. Okay, sorry, one thing. In the problem, sorry for the disturbance. In the problem, we already have the Lx mx. This is problem. Sum is starting from here. Okay, we have already the value of Lx mx x, that is 40.55. and summation of LXMX is 16.30, and obviously t value is 2.49. Here, so R0, that means we already have understand that R0 equals to summation of LXMX. So here the R0, the value of R0 is 16.30. Here, as R0 is equal to summation of LXMX, so we can say that R0 equal to 16.30. Okay, so here we just put the value of R0 here, ln R0 by t, that means ln 16.30 by 2.49, and the value of ln 16.30, that is 2.79. So by dividing 2.79 by 2.49, we get 1.12. This is one example of sum, and this type of example you already you will get in CSIR net. So I just here I explain only one sum of related to the R value. You just practice different types of sums that is related to the R value from the different books. Okay, and I think this helpful. This video obviously will be very effective or will helpful to you when you do the sums that is related to the R value. Okay, thank you.